In this example, we want to determine whether P, the vector with components 1, 0, 5, and Q, the vector with components 10, 3, negative 2, are orthogonal vectors. We'll do this by computing the dot product of P and Q. If the dot product of P and Q is equal to 0, then we know that the vectors are orthogonal. However, if the dot product of P and Q is any number other than 0, then we know the vectors are not orthogonal. So here we go to compute P dot Q. This will be 1 times 10 plus 0 times 3 plus 5 times negative 2. So this would be 10 plus 0 minus 10, which is indeed 0. So our dot product of P and Q is equal to 0, and therefore we know that these vectors are orthogonal. For this example, we want to determine for which value of x the vector P with components 2, 8, and negative 1 will be orthogonal to the vector Q with components x, negative 1, and 2. You can pause the video and try this example yourself, then resume the video to see the solution in a few seconds. We know that the vectors will be orthogonal when their dot product is 0, so we start by computing the dot product of P and Q. The dot product would then be 2 times x plus 8 times negative 1 plus negative 1 times 2, which will be 2x minus 8 minus 2, or 2x minus 10. We want to know when that dot product will be 0, so we will set 2x minus 10 equal to 0 and solve for x. Doing so results in x equal 5. So the vectors P and Q will be orthogonal when x is equal to 5, and they will not be orthogonal whenever x is a number other than 5.